Hey everyone! Alright, so I'm going to show you real quick how to find slope and really explain what a slope is and why we care about it. So I have made up a graph here and I picked some random points. I drew a best fit line. The first thing we always have to do when we have a graph is we have to decide, is it a horizontal pattern? Is it a proportional pattern? Or is it a quadratic pattern? So horizontal pattern, that was our pendulum lab. And if you think about a horizontal pattern, it is a line, a best fit line, that doesn't have any slope. It stays at one value and continues at that value. So if we look at this, this is not a horizontal line. This has a positive slope, it's going up. If it was horizontal, it would just be a straight line across. And that's not what we have here. So this is not a horizontal line. The next option we have is proportional, and this was the Benson on Board lab. And if you think back to that and you think back to the graph that we got, it looks something like this. So it had a slope. It might have been, if you had an easy push, it might have had a really relaxed slope. If you had the hard push, it could be the really steep slope. But if we look at this matches that proportional line. We've got a constant speed, we've got a constant slope. It is a stick straight line at an angle. So our graph here is proportional. Okay. So the second thing we have to do is figure out what the slope is. So whenever you find slope, the first thing that you're always going to do is pick 2 points. And it doesn't really matter what 2 points you pick, but whenever I do this, I usually pick the first point to be at the y and x intercept. So I'm going to make this really big so you can see it. This is going to be my first data point that I'm going to use to find the slope. The second data point, it doesn't really matter which one of these you pick. The farther away from this first data point it is, the more accurate your slope is going to be. So because of that, I'm going to pick this one. So I'll make this a big green dot so you can see it too. Okay, so we took notes on this. The slope, our equation for slope, is always going to be rise over run. Rise over run. So I'm going to make a little triangle here, and I'm going to label this distance between our dot and the x-axis. This is our rise. And this distance along our x-axis, this here is our run. So we just need to calculate how far is this and how far is this. So if we look at our rise, we start at 0 and we go up to 80. So our rise for this is going to be 80. And then we need to divide it by our run. And if we look at our run, it starts at 0 and goes to 5, 10, 15, 20. 20. So 80 divided by 20 equals 4. So that is going to be our slope. Now you may be asking yourself, Mrs. Benson, why do I even care about slope? And that's because our slope is our A value for our best fit line. So I can take that, and I don't even need Desmos. I can just say, okay, this is the A value. Then I know for sure, based on the different Desmos labs that we've done, is that D equals our A value, which is 4 times T. And boom, we've got our equation. Okay, so hopefully this helps. If you still have questions, email me, email Mr. Reynolds. We're here to help you. All right, bye.